Alright, hello everyone. So let's start partial fraction decomposition officially, okay? So remember the case that we are in. We are in case 1. So what is case 1? Well, when a fraction is given to you, when a rational function is given to you, when you compare numerator and denominator, denominator always has the polynomial with the highest degree, okay? So numerator versus denominator, denominator has the polynomial with the highest degree. So that's case 1. Now under case 1, if we go furthermore, we are dealing with the case where when we factor the denominator, we always get distinct linear factors. Now what do I mean? Distinct means different factors. Okay, all the factors are different from each other. I mean, the factors are not repeatable, okay, not repeating factors. And then linear means in each factor, the power of the x term, the power of the variable, the maximum power is 1. So we are dealing with that case, okay? Alright, so let's start. Now where do we start? The very first thing that you do is when a fraction is given to you, factor the denominator as much as possible, okay? Alright, so let's say you factor the fraction and you will get distinct linear factors. Now distinct linear factors will be like, let's write a couple in a general sense. Ax plus b, a and b are some numbers, cx plus simple d. So let's say these are the two factors. Now the rule is when you have distinct linear factors in the denominator, in the decomposition, okay, for each linear factor there will be a corresponding fraction in the decomposition in a specific format. What do I mean? So let's say these are the factors that you get from the denominator. Okay, perfect. Now take each factor. So let's take the first factor. For this factor there will be a fraction that look like a constant over ax plus b. And for this factor, we will have a fraction, a different constant over cx plus d. So for each factor, you will have a corresponding fraction that look like a constant over that linear factor. Now, why there is a constant? So the rule here is, the idea here is, whatever you have in the numerator, the polynomial that you have in the numerator should be a polynomial 1 degree less than the denominator. Now the denominator is ax plus b. That's a linear factor, right? That means x to the power 1. Degree is 1. So 1 less than 1 is 0, right? What is a 0 degree polynomial? It's a constant. Okay, that means x to the power 0 means x to the power 0 is 1, so it's a constant. Okay, alright, so constant over that linear factor. That's what happens when you have distinct linear factors. Well, let's look at some examples. Trust me, this is the easiest case, and when you see the examples you will get it for sure. Okay, what are these stuff? Alright, now what is the first thing you do? Factor the denominator as much as possible. So this will be x plus 1 over, let's see, x minus 3, x plus 2. So I factor the denominator. Okay, you should know how to factor quadratic functions, okay, by now. Alright, now what did I say? For each factor you will have a corresponding fraction in the decomposition. So let's take x minus 3 factor. So it will be a over x minus 3 plus, okay, we can write it as a combination of addition. For this factor, capital B over x plus 2. Very simple. That's the decomposition. Okay, for each factor there will be a corresponding fraction. Let's do another one. So here let's factor the denominator. What do we get? X plus 5, x plus 4. Well, let's change this 5 to 9. Okay, just to make sure that we don't have the same fact in the denominator and numerator. That was a mistake in my part. Okay, so I changed the question. So for each factor, so for x plus 5, a over x plus 5, plus for the other factor, b over x plus 4. Very simple. Let's do some other questions very quickly. So 2 over, let's factor this. So what do we get? X minus 7, x plus 2. Yeah, so for x minus 7, a over x minus 7 plus b over x plus 2. Does it need to be addition? No, it does not need to be. You can have subtraction, but it's easier to have addition there. Okay. All right, x plus 8 over, if you factor this one, you will get 2x minus 1, 2x plus 1, x minus 3. Let's see. Yes, so now a over 2x plus 1 plus b over x minus 3, a constant over each these factors. Okay, so the last problem. Now here they have already done the work for us. They have already factored the denominator. So for each factor in the denominator, we will have a fraction. So the decomposition is a over x plus 7, for x plus 1 b over x plus 1, and for for x minus 3 c over x minus 3. That's the decomposition. So it's very easy to write the decomposition when you have distinct linear factors. Now the question is how to find this a and b, or an a, b and c. How do you find those numerators? Because the final step of decomposition is to evaluate these constants. Okay, you have to find these constants. But here's the thing, I do not want to focus on finding constants right now. Let's do that like couple of more videos after, because let's first go through several cases, different cases, like what do you do when you have repeated factors? How do you write the decomposition? For example, here if I had x plus 5 square, what do? We can't do the thing that we just did here. Okay, so what do we do when we have repeated factors? What do we do if we have non-linear factors, like second degree factors, third degree polynomials as our factors? What do we do? So let's learn how to write the initial step of decomposition, and then evaluating constants is same for all the cases. Okay, we use the same process. So let's learn how to evaluate constants like couple of videos after. All right, so I'll see you in the next video to learn how to decompose when you have repeated factors in the denominator. Okay, I'll catch you there. Bye bye.